Food. Few things touch our lives so profoundly. It sustains us, of course. It also provides enjoyment and a time for us to connect as family and as friends. But food is also a very important business. Starting on the farm and throughout the production chain, the food industry is driven by technology. Because food is so important to us, new technologies sometimes promote serious public discussion. When ancient Egyptian farmers began to choose seeds from healthy plants exhibiting favorable traits, such as size or flavor, they were defining the ongoing goals of agriculture. In nature, birds and insects transfer pollen from one plant to another. A new combination of thousands of different traits or genes from both parents is expressed in the new plant. This results in changes from one generation to the next. By identifying these naturally occurring variations, man has, over many years, directed the evolution of both plants and animals. Along the way, breeding advances, such as hybridization of plant stock and artificial insemination of animals, have allowed farmers to optimize yield and improve palatability. The most dramatic increases in productivity have come in this half-century. Since 1960, we've doubled food output throughout the world. In the United States, where production and yield were already high, in that same 30-year period, we have more than doubled the yield of soybeans and wheat, tripled the yield of cotton, and increased corn production fourfold. While advanced breeding has been responsible for much of this increase, so have chemical fertilizers and pesticides, as well as improved mechanization and better management practices. In 1950, U.S. families spent about 1/4 of their income on food. Today, that percentage is down to 1/10. This is much lower than in most developed countries, and substantially lower than in the underdeveloped world, where 60 to 80% of income may be spent on food. Even with today's technology, we are losing ground. World population will nearly double to 9 billion people in the next 40 years. The developed world must help feed these people, but we have an obligation to do so without harming the environment. In the past, low-yield farming techniques in underdeveloped areas have sacrificed rainforests and other natural habitats to accommodate the expanding needs of growing populations. For the past few decades, field tests have been conducted on a wide variety of products that may provide a better answer and may herald the latest revolution in farming techniques, the products of agricultural biotechnology. An Augustinian monk, Gregor Mendel, began to unravel the secrets of genetics. Working in the monastery garden in Czechoslovakia around 1860, Mendel documented the inherited qualities of garden peas and flowers. Each trait he isolated was found to be transmitted from one generation to the next by a discrete, independently inherited unit, later called a gene. His discoveries were largely ignored until the 20th century. In 1954, Watson and Crick began the process of unraveling the secrets of genes when they discovered the structure of DNA, the long strands of molecules in chromosomes that carry all the genetic information in every living organism.
But remember what we didn't understand, that the answer was going to come out in such a dramatic way, and that the structure would tell us so much. We didn't know that. Of course, when we saw the structure, then of course we immediately recognized, I mean the same day, you might say, we immediately recognized most of the implications.
The implications were profound, but practical applications of this breakthrough had to await the development of recombinant technology in 1969. This made it possible to isolate specific gene segments, cut them out, and transfer them to another genetic structure. This is a targeted, controlled version of what happens in nature when change occurs. Although nature's process for passing on the complex genetic code is remarkably accurate, variations do occur and generational change results. These will survive if they're better suited to their environment. The color of a flower, for example, might mutate naturally from yellow to red. If it can successfully attract birds and bees, it may survive as a red flowering plant. Mimicking this natural process, biotechnology allows us to identify and isolate desirable traits and introduce them into targeted plants. The principles of breeding are the same, but the tools are much more accurate and more effective.
Genetic engineering allows us to be more precise in the way that we improve our crops. We know exactly what we're going to end up with. We don't know that in traditional breeding.
In general crossbreeding, you're taking individual organisms with thousands of genes apiece and seeing what comes out. It's a much more random process. The biotech is a much more predictable process.
What we're seeing is just a more modern way to produce better crops. To me, it's no different than genetic plant hybridization that we've done for 100 years.
Not everyone agrees. In part, there is a natural distrust of new technologies.
We must not.
These familiar sentiments may sound like contemporary concerns. They were actually made early in this century, in opposition to milk pasteurization. So what role should public opinion play? 20th century agricultural practices involve complex issues.
In terms of productivity and net farm income, agricultural chemicals are probably unequaled in their impact on the farming community. So there was a net increase in farm income, but the main benefits were accrued to consumers who saw lower prices and a more stable supply of food in the marketplace.
But some chemical insecticides and herbicides, like antibiotics in human medicine, are becoming less effective. Nature continues to develop resistance.
I'm very concerned about the development of resistance. We're seeing resistance in insects, we're seeing it in weeds, we're even seeing it with plant diseases.
As the effectiveness of chemical pesticides declines with specific crops, farmers look for other solutions. Biotechnology may provide one answer. For example, field tests have been conducted on a potato plant that actually contains its own insect protection in its genetic structure. Instead of a chemical insecticide, this genetically modified potato plant uses the same protein that is produced by a common soil bacterium, Bacillus thuringiensis, or Bt, commonly used by organic farmers. This protein protects the plant from the #1 pest plaguing the potato farmer, the Colorado potato beetle. The effect is very specific to the beetle and has no effect on humans, animals, or other insects.
The worst thing about this pest is that uncontrolled, it will destroy the entire crop. They have an unbelievable appetite, and they have an unbelievable capacity to reproduce.
Basically, they've taken the gene from this bacterium that produces this protein, and they've taken that gene and through the use of what we call recombinant DNA technology, they've been able to insert that into the potato plant. Now, that gene produces the same protein in the potato plant that it produced in the bacterial species that it came from.
It's amazing. It is 100% effective, controls the beetles completely.
The potato plant on the left has been modified to be insect protected. The one on the right is unprotected. As genetically altered plants such as this potato are introduced, work is being done to safeguard against future resistance issues. But their value as a part of the farmer's integrated pest management system is significant.
We no longer have to use insecticides in these fields more than once a year. That means a reduction of 5 to 6 applications of insecticide in a year's time. That means a lot less residues, means a lot less impact on the environment, and it means lower cost.
These field tests suggest an additional advantage. When such targeted approaches are used, the beneficial insects common to these fields are allowed to flourish again. These beneficial populations, normally reduced or destroyed when broad-spectrum chemical insecticides are applied, can provide additional natural pest control. Farmers like Ron Ryman realize the advantages.
So that's why I get excited about this thing. If we don't have to put that chemical on and we can allow the beneficial insects to spray, we have no idea what we can do then. I mean, those beneficial insects may do everything for us, like they do in my field corn.
I see biotechnology as providing a whole variety of tools, crop protection tools, essentially for the farmer.
Even if biotechnology does lead to a more sustainable approach to farming by offering new approaches to controlling insects, viruses, and other pests, feeding the world in the 21st century will require more than improved production.
We do need greater production, but then we also need more efficient distribution, and that's where some of the applications of biotechnology will be very helpful.
The estimate right now is we lose 80% of the world's banana crop to rotting. We can't get the bananas to where they need to go.
Similar waste occurs with other staple crops. In developing countries, improving distribution through biotechnology may mean that people who would otherwise go hungry can be fed. In the United States, the impact is not usually as dramatic, but the promise of an improved food supply is still significant. In a genetically modified tomato, already available in supermarkets, the gene that causes the fruit to soften was identified and isolated. By copying the gene and reinserting it in reverse, the ripening is slowed instead of accelerated. Now, instead of picking the fruit green and immature so that it will remain hard enough to survive the journey to the market, the new tomato is allowed to ripen on the vine to its full flavor potential. Working on the level of genes, other approaches to slowing the ripening process will also delay the rotting process. These approaches will be applied to other crops and could help to reduce the massive spoilage of food around the world today.
If we could use the technologies that have been used to develop the flavor saver tomato for a longer shelf life to crops such as mangoes, papaya, and bananas, the amount of food deterioration would drop dramatically.
But the development of such modified crops is expensive, requiring years of research, testing, and approval. The continued interest in such research and development depends to some measure on the commercial and financial success of these products in developed countries.
We have a great luxury in this country in assessing things like biotechnology because we don't have a need for it particularly. You would look at this kind of an issue in a very different way if it was about feeding yourself as opposed to, does it make you feel real comfortable?
How will those who are concerned become comfortable with these new products? Terry Medley of the USDA.
As a federal regulator, my responsibility is to assure to the public that those products I'm responsible for, that I have an adequate, comprehensive system in place to assure safety. Whether or not you then purchase product A or B is a marketing decision. But the ability to place it on the market is a regulatory decision.
Very easy to throw fears and concerns to the press or to the public in speaking audiences. It's more difficult to highlight the exceptional opportunities in biotechnology. For example, most people don't know that as much as 40% of the insecticides in the U.S. are used to produce cotton. And if there's a way to reduce that by 10 to 15%, if you tell an audience that we can reduce the load of insecticides by that dramatic amount through biotechnology, it gets a favorable response. Very seldom is that kind of information provided.
Is it an equal trade-off? I don't know, because again, I'm not convinced. You know what? I don't think there's anybody that really knows what the long-term effects are going to be, So, is it better not to use pesticides and have the thing genetically engineered? I don't know.
Working for American Farmland Trust, I sort of straddle between the environmental community and the farming community. I see real benefits to the farming community in providing farmers with tools that will help them protect the environment and help protect their net farm income. And I see real benefits to the environmental community in that we will have technologies that will maybe lessen the impact of the technologies that we're currently using.
Many people do think that the technology is developing too fast. We would actually say the opposite. We think it is developing very slowly, but we do have tremendous respect for the very stringent review process that FDA and other agencies apply to new technologies.
The products of biotechnology are really looked at based upon what is the product, is it a food, is it a pesticide, is it used to prevent disease, insect pests, and then it's regulated by the agencies that have been regulating those products for decades. The Food and Drug Administration, the Environmental Protection Agency, the Department of Agriculture.
Despite a remarkable food safety record to date, Our government agencies and the scientific community are challenged by critics over the potential development of unforeseen complications in the new agriculture.
Biotechnology, to a great extent, is an emotional issue. It's what I always say is the fear of the unknown. Technology to me means it makes my life easier or safer, and that's really what we have to get across to consumers, that it's not science run amok. This is very planned, very well researched.
I can only prove to you through science that what we have done is safe. Now, if you as a consumer are unwilling to accept a scientific validity of my studies, that's another issue.
As the FDA considers the introduction of genetically modified foods, safety issues such as food composition, nutritional profile, and nutrient availability are addressed. Particular attention is focused on the potential transfer of allergens from one food source to another. Because a food may now contain a gene transferred from a different plant, the question is, will the new variety assume any allergenic characteristics from the original plant? For instance, if a gene from a peanut plant were introduced into a variety of carrot, will the carrot assume the allergic characteristics of the peanut plant? The scientific issue here is that each plant has hundreds of thousands of genes, only a very few of which lead to allergic reactions, and those would not be the genes scientists would choose to move to another plant. From a regulatory perspective, the FDA requires labeling if a gene from a known allergen is introduced into a food. The practical issue is that most food companies would be very reluctant to introduce a potential allergen into a food. There's no incentive to develop a food that would have such limited marketability. Meanwhile, in the fields of medicine and pharmacology, biotechnology is being heralded as an unparalleled revolution. Dr. Roy Schwarz of the American Medical Association.
It's the most profoundly revolutionizing change in medicine in the history of the world. And over the next 20 to 30 years, we're going to learn more about what really constitutes health and disease and how you treat it and how you prevent it. Enormous insights into growth and development, enormous insights into cancer, enormous insights into birth defects. And all of this is wrapped up in the products that are coming out of the biotech efforts at this point. If I could go back and start medical school right now so that I would have 40 years of a career after that to see this unfold, I would do it in a minute.
Most people share Dr. Schwarz's opinion. Research shows that only a small minority oppose the development of genetic techniques in medicine, and that over 2/3 of the American public support biologically improved foods. Several food products have been approved and accepted by the public. Since 1990, for example, much of our cheese has been produced using a biotech version of rennet, an enzyme commonly used in fermentation. Previously, this enzyme could only be obtained from the stomach lining of newborn calves. Genetic research has been conducted around the world for over 30 years. This work has not identified any increased risk to public health or environmental integrity. Despite this evidence, as well as the formal positive positions of the leading health organizations, some people remain skeptical.
I believe scientifically it's a significant and important tool. I remain slightly cynical on the motivations of the proponents of biotechnology.
Will the success of biotechnology in developed countries be transferred into developing countries? And besides improvements such as increased pest protection and improved handling and storage, how else may biotechnology enhance the world food supply?
So we see just being able to increase the availability and the quality of products as hopefully being a way to encourage consumers to buy and consume more fruit and vegetables.
Because biotechnology allows us to isolate a characteristic at the gene level so specifically and to transfer an individual trait, improvements in the taste and nutritional quality of our produce are a very real promise. Historically, farmers have done this through conventional breeding and hybrid approaches. Corn is a good example. Originally a tall range grass with few seeds, it was engineered by farmers over several hundred years into its modern varieties. If, for example, in the next few years we succeed in genetically reducing the saturated fat content of corn oil, the dietary impact of that single improvement could have far-reaching implications. Similar work is being done on other important sources of vegetable oil, including soybeans and canola. On another front, work is being done to develop a potato with a higher level of solids. This means that the potato will absorb less fat when it is fried into chips or French fries.
Similarly, there are lots of applications globally, opportunity to increase protein or vitamin content of common food products, and that's of great interest to us.
An example, strawberries are being developed with higher levels of a component that may help reduce the risk of cancer. Besides improving the nutrition profile of crops, in the future some species may also be made more tolerant to their environment. What if frost-sensitive trees, such as citrus and coffee, could be made genetically resistant to frost damage? Even further in the future, it's possible to imagine crops made saline tolerant so that they could be irrigated by salt water. Precisely because the potential is so great, some question the future. Some environmentalists challenge whether we can calculate the total impact of some of these changes on our ecosystem.
I would say that the moderate environmental groups right now support biotechnology with some provisions. In other words, they want to make their decision based product by product.
The way to save the world and its environment is not to put everybody back in mud huts and have them die early. The solution to the environmental problems is to pull people through the most polluting phases of economic growth. The solution is to pull those billions of people on into the Silicon era, where they're using non-polluting technologies and caring about the environment and wildlife.
Another charge is that technology is moving us away from the family farm towards the large business farm, and that biotechnology will accelerate that movement.
I don't think biotechnology will change the trend in agriculture any more than economics has already done. We see fewer small family farmers and larger farms develop, and it's a matter of economics.
It isn't going to put the smaller grower out of business. I mean, in a lot of cases, I think it may be of more benefit to the smaller grower that is working on a tighter budget, where that extra dollar to spray is very important to him.
So where does the public get accurate information on such a complex issue?
Well, consumer surveys show repeatedly that consumers most trust are health professionals, and particularly dietitians. And that is why the American Dietetic Association took a very strong positive position in support of food biotechnology.
Even if all the issues are answered, the question for some is why? Why do we need agricultural biotechnology?
What biotechnology is going to do is help the plant breeder to continue to achieve its goal of increased productivity over the next 20 years in small increments, not as a big, massive change, but in small increments. If we could simply distribute the foods that were made grown around the world into the places that need them, we'd solve the problems. On the other hand, do we want to see ourselves only as a distributor and not a helper, an implementer of self-sustenance and self-sustainability? And I think the latter is the case.
We don't have the farming resources in hand to triple the world's food output again without plowing down wildlife habitat. We need additional research. And in fact, the plant breeding, the chemical fertilizer, and the irrigation that gave us the threefold increase in farm resource output in the last 30 years are probably not going to be enough to do it cost effectively in the next 30 years.
The fertilizers Dennis Avery mentioned present a significant opportunity. Farmers in most countries cannot hope to spend anywhere near the $12 billion a year that American farmers spend on chemical fertilizers. But perhaps in the next century, we will develop crops that will draw nitrogen more efficiently from the soil and air and dramatically reduce the need for topical fertilizer applications. Even small incremental increases in productivity on the subsistence farms of developing countries will improve many lives. For that reason, extensive research is being conducted around the world on specific local agricultural problems.
Several years ago, I met a very bright and ambitious woman in Africa named Florence Wambugu. Her interest was in sweet potatoes and viruses that affect sweet potatoes. I saw, and as others had, that she is a very exceptional woman. And because of that exceptional capability, we made arrangements for her to come to the U.S. for advanced training. She did that at the Monsanto Research Company.
The sweet potato is a much more important crop in Africa than in the U.S., but the sweet potato in Africa is plagued by a virus. The average yield is less than half the yield on American farms. Most African farmers cannot afford the chemicals to control the aphids that spread the virus. Genetic engineering is offering a different solution.
The major problem is this virus disease. And so by just fighting this one disease, we can double the yields in Africa. And so it's because of major impact.
If the virus can be controlled and the sweet potato yield increased by 50%, the effects go beyond eliminating starvation. If the potatoes can be harvested, processed, and sold in Kenya, an entire economy may be developed and countless jobs created. That is Dr. Wambugu's mission.
Our need is greater, and so I believe our decision making is going to be based on real issues other than imaginary things.
Dr. Wambugu recently returned to Kenya, where she continues her research and field testing. She hopes to have an approved product available before the end of the decade.
It's a very moral obligation that we have, and hopefully as the industry progresses with the commercial side, that enough funds are created to help us on the third world side, rather than just continuing giving them aid, actually give them product they can grow and become self-sufficient with. That's hopefully the destiny of biotechnology.
I'm convinced that if we continue down this path of carefully developing technology that's useful and that's safe, we're going to be able to achieve higher levels of food with less damage to the environment and increased nutritional quality and availability for the consumers.
This is one of the fundamental advances in human knowledge. This is going to rank with the invention of vaccinations. It is going to rank with the computer. And it's kind of comparable to looking at the airplane in the year 1912 and wondering what it's going to do for you.